Hello everyone, today I will talking about Ender 3 V2 display. Let's see. At the front, we have LCD based on the TN panel, I think. There have additional matte screen protector. I don't know for the resolution, but the brightness is enough for me at the indoor use. But it's not adjustable. Sadly, my LCD suffer from little was out at the corner. From my experience, it's because humidity. But it's not my fault. It's because LCD insulation is not perfect. And the last we have rotary encoder, and that's it. At the back we have more interesting component. First, they have 10-pin connector for connecting to main board. And I think they have 3 or 2 auxiliary power supply. Here, here, and here. The microcontroller itself comes with microSD card reader for flashing firmware. And this is the main microcontroller with microSD card for flashing firmware. The last thing is tiny buzzer compared to old model Ender 3. Now let's see closer. After 10-pin connector, we have Schottky diode for reverse paralytic protection, and also likely Zener diode for limiting input voltage at 5 volt maybe. After that, we have 2 or 3 auxiliary power supply. The first is bus converter non-synchronous with Schottky diode. It's okay for high voltage, because diode voltage dropout not very important at high voltage. This buck converter is for driving LED backlight LCD. I hope this circuit working with constant current mode. I don't really see the current sense resistor, and the track goes to somewhere below. At the input and output, they have big capacitor. Next, as we know, the LCD need have LCD display connector IC. The IC location normally fused into the LCD glass, and this chip need to be the power, but I don't know why they need to be separated power supply. Here. The power supply itself, I don't know, it's charge pump or low dropout regulator. I will test later. The last is buck converter with synchronous rectifier. I think that's overkill for low current, even it's low voltage. This buck converter is for powering the microcontroller, and the rest thing like microSD card reader. Rotary encoder and beeper is directly powered from VCC. For 10-pin connector, I think it's not compatible with all model, or maybe my testing with continuous mode is mistake. I think little bit odd, because nowadays 3D pin that come with this color LCD, they have 2 microcontroller. The morality is beeper and rotary encoder keep directly communicate with the main controller from 10-pin connector. Later, the main microcontroller and the display microcontroller communication with UART from 10-pin connector too. Maybe they keep compatibility with Marlin firmware or the other 3D print model. The microcontroller itself is the Duine T5. The manufacturer said it's dual-core microcontroller. The PCB design is better than the Creality have. It's more proper, I think. And the build quality like PCB and component thickness is good. But hence TST soldering is bad. They very attentive about the interference filtering here. If something shorted, you need to check input Zener diode, capacitor, and other capacitor, controller and diode at other 3 power supply. Now the power consumption is about 70 milliamps. So the LCD itself consuming about 10 milliamps. Okay, now at bus converter for LED backlight, we have about 12 volts. At LCD driver, we have about 3.3 volt. And the last thing is buck converter for microcontroller. We have about 1.2 volt. Yes, 1.2 volt. This bus converter oscillate at 1.2 megahertz. and this buck converter oscillate at 560 kilohertz. Okay, thank you everyone for watching. I hope you learned something new from this. If you have question, you can drop comment below. Follow my social media and visit my website for something interesting. Bye.